So welcome to another series. What I want to do in this next set of videos is talk about the implementation of security. And I've tried to divide the video into segments. So today I want to look at the system development lifecycle, SDC, and software assurance. They're somewhat related. The significant is what am I trying to do in that description, right? So let's go to the beginning of our slide deck and try and make this as short as possible. Again, I'm going to change the title SDLC, System Development Lifecycle and Software Assurance, if you see the video title, right? Again, that's information about me, where I teach, how to connect, our caveat about what we're using, right? So I want you to, upon completion of this module, to understand, or at least be able to describe SDLC and see how an organization information security blueprint becomes a project plan. Then after this, I'll do another video on the importance of product management in cybersecurity, and then we'll do one on change management. So essentially, information security must be implemented in every major system in an organization. We also say sources should be designed into every system from the inception, from the beginning, and throughout the entire phase of development and deployment. It used to be you have a security that is bolted on. Now we say it should be part of the implementation. One of this approach is to ensure that the security is actually a fundamental part of the system development lifecycle. So there is some innovation in the system development, which include what's called a joint application development, rapid application development, agile programming, AP or extreme programming, and then development operations, DevOps, like a master's class that I teach at the university. And they also have SecDevOps, which is security development operations, right? So what all the SDLC or system development lifecycle is just a methodology for us to design and implement our information system. So the benefit here is by using this methodology, just make sure that we have some kind of clear process, a scientific process with defined goals, and it tends to increase the probability of success. So once we adopt this methodology, we now have milestones, key milestones, and of course, we now select our team and we make them accountable for the project goals. So this is the waterfall methodology. You may have seen this. This is the system development lifecycle, SDLC waterfall methodology, right? We start from our investigation to analysis, logical design, physical design, implementation, maintenance, and then the change. Traditional phase of this SDS is what I just showed you, right? So the investigation means what is the problem that the system is being developed to solve? The analysis means we need to figure out what this system is expected to do and how it will interact with existing systems. The logical design will be the blueprint for the design solutions. And of course, physical design means we're going to select the technologies to support the what we've identified as our alternatives. Right? So many organizations, they see the need for this. So they plan into their software development the objective of SDLC. So we now call this this approach is called software assurance, right? So software assurance, or SA, is just we're planning for security objectives in your SDLC, right? So that we make sure that we create systems and we have established procedures to create software that is more capable of being deployed in a secure fashion. So the whole idea is to intentionally create software free of vulnerabilities and provide effective, efficient software that users can deploy with confidence. Say, hey, I did this and I don't have any issues with that, right? So any software developer should be aware of the OWASP Top 10, which is the Open Web Application Security Project. There's also one called OWASP Top API Security Issues. You will see from 2017 to 2021, the difference in terms of the vulnerabilities in applications. Like we went from injection, now the top one is broken access control. You can research all this. Many times they repeat themselves, right? All right, so what is our software design principles? We always want to think about economy of mechanism, our fail-safe defaults, complete mediation, things like open design, separation of privileges, and of course, the doctrine of least privilege. You also have something called least common mechanism. The NIST, which is the US agency, has an approach to securing the SDLC. So it says from system inception, right, from the beginning. So you must have the identification, the awareness, identification of shared security. So this is a comparison here. If you look at this chart, waterfall on the left side and the NIST SDLC, you see they kind of like relate. The first two of the SDLC is subsumed in the NIST SDLC phase of initiation, and then logical design, physical design are part of the development, so acquisition, and then you now have implementation, and then implementation assessment, and then finally maintenance and change in waterfall, operation, maintenance, disposal in NIST. So this would be relating security consideration in the initiation phase, the development acquisition phase, implementation assessment phase, operational maintenance phase, right? And then finally in the disposal phase. In other words, there should be security considerations in every single phase. Now, most people do not know this, but Microsoft in 2002 actually suspended development work on one of the servers. They actually made it mandatory. They stopped and then now put the developers, the testers, the managers through an intensive program that focused on secure software development. And it's because it delayed their flagship operating system. They wanted to address critical security challenges. Many organizations end up following Microsoft lead in putting security into the development process. Since that time, we noticed that many Microsoft developed its own security development lifecycle, which is what I call 7 phases with 17-step methodology that culminates or ends in executed incident response. So this is the Microsoft software development lifecycle. See how it goes: training, requirement, design, implementation, verification, release, all the way to the end, right? So please feel free to send me any questions. This is system development lifecycle, or you can also relate the software development lifecycle. We've also covered the Microsoft's own version. Send us any questions, subscribe to the video, follow us. And then again, it's Professor Alex, and we just finished talking about system development lifecycle. And we'll follow up in the next video on the importance of project management in cybersecurity. Thank you.